Welcome to my channel and hello to you math lovers. Get ready to unlock the mystery behind the exact value of sine of 6 in this exciting video. Throughout history, mathematicians have always grappled with trigonometry calculations, and today we're taking on the challenge ourselves. So join me as we explore the step-by-step process to calculate the precise value of sine of 6 using powerful trigonometric techniques. Whether you're a math enthusiast seeking a deeper understanding or just a student preparing for an exam, this video is your comprehensive guide to mastering the calculation of sine of 6 like a pro. So let's embark on this mathematical adventure and unveil the exact value of sine of 6. So, first of all, I have to say that we can perhaps use Taylor series to calculate an approximation for sine of any angle. And you know Taylor series can be written as x minus x 3 over 3 factorial plus, I think you know the rest of the terms. But that's not what we want to do. So how can I go about this this problem? How can I calculate the exact value of sine of 6? This is how I did it. So sine of 6 can be written as sine of 60 minus 54. I hope you agree with me on that. And if I expand this using trigonometry, a famous trigonometric identity, then this can be written as sine of 60 times cosine of 54 minus sine of 54 times cosine of 60. And I hope you agree with me that sine of 60 and cosine of 60, these two guys, we already know them. Okay, they're very famous. So let's start with sine of 54. Sine of 54 can be written as cosine of 90 minus 54. Again, this is a known trigonometric identity, which is basically cosine of 36. But that can be written as 1 minus 2 sine 2 of 18. And by the way, cosine of 54, so these two guys which I have here, cosine of 54 can also, once I obtained sine of 54, cosine of 54 can also be obtained by using the famous identity, right? So yeah, but to find sine of 54, we first need to find sine of 18. So how to go about that? Sine of 18. So sine of 18 is nothing but sine of pi over 10. I hope you agree with me on that. So we want to calculate this, and as a matter of fact, sine of pi over 10, again, this is equal to cosine of pi over 2 minus pi over 10, and that is equal to 5p minus p, which is basically cosine of 2 pi over 5. I hope you agree with me on that too. So now let's consider a famous identity in trigonometry, which is basically sine of 2 alpha equals 2 sine of alpha cosine of alpha. And if I take alpha to be pi over 5, then what do I get? Then I have 2 sine of pi over 5 cosine of pi over 5. That is equal to sine of 2 pi over 5, right? Okay. Also, if I take alpha to be 2 pi over 5, then I also get 2 sine of 2 pi over 5 cosine of 2 pi over 5. This is equal to sine of 4 pi over 5. But pay attention that sine of 4 pi over 5, as a matter of fact, this is equal to sine of pi minus 4 pi over 5, which is sine of pi over 5. So I'm just basically using this identity. Sine of pi minus alpha equals sine of alpha. All right. So now next I want to draw your attention to these two equalities here. So if I multiply both sides of these two equalities, maybe I'll do it with a different color. So pay attention that this guy here, note that this guy will be cancelled with this guy, and I have sine of pi over 5 which will be cancelled out by this guy here. So in other words, I can write the equation as 2 times 2 cosine of pi over 5, okay, times cosine of 2 pi over 5. This is equal to 1. And as a matter of fact, then I can say, yeah, just maybe bring 4 to the other side, and let's say just say this guy equals 1 over 4. Okay, we have this identity here, which is interesting because pi over 5 is 36 and 2 pi over 5 is basically 72. So we have this guy, and then also I can write the following: cosine of pi over 5 minus cosine of 2 pi over 5, using again a famous identity, which is basically, maybe I can write it here for you guys. So cosine of A minus cosine of B, this is equal to minus 2 sine of A plus B over 2 times sine of A minus B over 2. So if I use this identity, then what do I get? So A minus B here is also negative, and then that minus here will disappear, just for you to know why I didn't write it. So this is basically 2 sine of their average, which is basically 3 pi over 10, and their difference. Sine of pi minus 2p is minus p, and basically will be cancelled with this minus here, and that is pi over 10. Okay, so but let's take this identity again here and write it: cosine of pi over 5 minus cosine of 2 pi over 5. Well, instead of sine of 3 pi over 10, I can write, I can use the, again, famous identity, cosine of pi over 2 minus alpha. So then I can just write 2 cosine of pi over 2 minus 3 pi over 10 times cosine of, I think I can also here do the same, pi over 2 minus pi over 10. So this is equal to 2 cosine of 2 pi over 10, which is basically pi over 5, right? Times cosine of 2 pi over 5. But we already had here an expression based on the multiplication of these two guys. That was 1 over 4, so this is basically 2 over 4, and this is nothing but 1 over 2. Perfect. So if I take cosine of pi over 5, let's say as x, and I take cosine of 2 pi over 5 as y, then this identity here, which I had, that one suggests x times y equals 1 over 4, and this guy here suggests that x minus y equals 1 over 2. Okay, so this is a very easy system of equation, can be solved easily, and I just need to replace y by x. Then I get x minus 1 over 4x equals minus 1 over 2 equals 0, and then this gives me basically x2 minus 1 2x minus 1 over 4 equals 0, and as a matter of fact, x equals 1 over 2 plus minus squared root of, so let's say, I think, yeah, plus minus square root of 1 over 4 minus plus 1 over 2, and that is 1 over 2 plus minus square root of 5 over 2 divided by 2, which is basically 1 minus plus minus square root of 5 over 4. But again, please note that minus is not accepted because cosine of pi over 5 is between 0 and it's basically pi over 5 is between 0 and pi over 2, and that cosine must be positive. So minus is not acceptable, and we just take x equals 1 plus square root of 5. So therefore, then I have cosine of pi over 5 equals 1 plus square root of 5 over 4. Okay, perfect. So we calculated the cosine of pi over 4, and so let's see what is cosine of 2 pi over 5. Then that is basically, we can also use this identity here. So that is 1 over 4x, and that is nothing but 1 over 1 plus square root of 5. But that is also, yeah, you can just multiply numerator and denominator by the conjugate value of it. So this guy here, 1 minus 5, which is minus 4, and that gives me square root of 5 minus 1 over 4. Okay, but you remember that cosine of, if you go back to what we found here, so sine of pi over 10 was equal to cosine of 2 pi over 5. So in other words, here I have obtained sine of 18. Okay, so in other words, sine of 18 equals cosine of 2 pi over 5, and that is square root of 5 minus 1 over 4. Perfect. Now if I go back to the equation which I derived in the beginning here, then I can calculate sine of 54. So let's do that. So sine of 54 therefore is equal to 1 minus 2 sine squared of 18, and if I just replace sine of 18, this is 2 times well, let's just raise that to the power of 2. That would be 5 plus 1 minus 2 square root of 5 over 16, which is basically equal to 1 minus, so this is 6 minus 2, so 6 minus 2 square root of 5 over 8. Again, this is 1 minus 3 minus square root of 5 over 4, and that is 1 plus square root of 5 over 4. So we calculated that, and cosine of 54 using the known identities is basically 1 over square root basically power 2 of this guy, and that is 1 plus 5 plus 2 square root of 5 over 16, and that gives me this. So 16 minus 6 minus 2 square root of 5 over 16, and that is 10 minus so 10 minus 2 square root of 5 over 4. Okay, let's just keep it that way. So you remember our formula. I don't go back up there again, but let's just write it. So sine of 6 was sine of 60 times cosine of 54 minus sine of 54 times cosine of 60, right? So if I just replace these values, then I get square root of 3 over 2. Cosine of 54 is just in front of us. That is 10 minus 2 square root of 5 over 4. And here I have sine of 54 was 1 plus a square root of 5 over 4 times 1 over 2. So I know that the second term doesn't look like what we had, but there is a trick to that. So basically, then this can be written as a square root of 30 minus 6 square root of 5 over 8 minus, well, I have 1 plus a square root of 5. If you remember, the second term was something like a square root. But then I can write that as a matter of fact as square root of 1 plus square root of 5 over to the power of 2, which is basically 1 plus 5, which is 6, plus 2 square root of 5. Okay? And this is divided by 8. This is precisely what we had. So I just use the fact that this is equal to 1 plus a square root of 5 to the power of 2. And yeah, we proved this identity. Congratulations. And we've successfully calculated the exact value of sine of 6. I hope you find this journey through trigonometry both enlightening and enjoyable. If you did, please don't forget to hit that like button below to show your appreciation for this mathematical exploration. And hey, if you want to join me on more exciting math adventures, make sure to subscribe to my channel and yeah, so that you never miss a video. Thank you for watching, liking, and subscribing. Until next time, keep exploring, keep calculating, and keep loving math.